So today we're looking at square root functions, which we've talked about a little bit previously, but now we're getting slightly more in depth with it. So here's our vertex form, right? A square root of x minus h plus k. So h and k are the coordinates of your vertex. And then a, same with quadratics. If a is positive, your function is going to open upwards. And if a is negative, it's going to open downwards. So we got a couple of functions here. We're going to sort of crudely graph them out so we can get an idea of what they look like, because what we want to know is what is the domain, what is the range. Okay, so if I see square root of x minus 2 plus 5, so my vertex, I'm going to take the opposite of what's on the inside for my x. That's going to be positive 2. And the number on the outside is the y-coordinate of my vertex, which is 5. So I know my vertex is somewhere out here at 2, 5. Okay? And then every square root function, it's sort of like a parabola, only instead of opening up or opening down, it opens to the right or to the left. So this is going to look something like that there. Actually, let's draw this a little different. I'm going to angle it upwards so we don't get confused later on. Okay. The key difference on a square root function, it only opens in one direction. So it either goes up or it goes down. It's not going to do both because of the way square roots work, and that if what's under the square root is negative, then it's imaginary, and then you can't graph imaginary points on a regular grid. Okay, so there's our whole graph. It's half of a curve pointing out to the right for the most part. Okay, and then I want to know what's the domain, what is the range. So domain is my x values, and on my number line, on the far left side is negative infinity, and on the far right hand side is positive infinity. And if I took it's a regular old number line here, on one side of that, we have negative infinity. On the other side, we have positive infinity. And then in the middle is, let's throw this down a little bit, literally any number, right? Whatever number you have, it's somewhere in between negative infinity and positive infinity. So that's going to help us with our domain. So since it's opening to the right, we know our smallest value has to be that number, right? Because as we go to the right, we head towards positive infinity. So I look at my x value. The lowest x value is that 2 there, 2, comma. And then the end point, doesn't actually have one. It approaches infinity, so I put that out here. And then here's our little notes on set notation. Since it's a closed circle, our domain includes the point 2, so we put a bracket, right? The bracket tells us that our domain includes that point 2, okay? On the other side, because we want to close out our set here, infinity is not a number, so it can't equal infinity. It can only get close to it. So if we're just approaching something, we put a parentheses instead. Okay. So we would also do that if this was an open circle, right? Like if we wanted to say greater than 2, then we would have put a parentheses here. So parentheses if it's approaching a number but not including it, and brackets if it does include it. And I'll give you a hint for all of our numbers today. It's always going to be a bracket next to it. Okay. All right. Then our range, we do the same thing, but with our y values. So we see, and this is why I redrew it, so we can see that it's mostly going to the right, but it's also going up. And on our number line, if we're going up, it's heading towards positive infinity. And if it was going down, it'd be heading towards negative infinity. So since this is going up, then our lowest value is 5. So we'd say the range is everything from 5 all the way up to approaching positive infinity. And then parentheses around that. Anytime you deal with infinity, always put a parentheses next to it. Because again, infinity, not a number. And there you go. There's your domain and range. Not too bad, hopefully. Okay, so our second function, so we're going to look at this -2 afterwards. So don't forget about that. Let's start with the vertex. So we have +3, -1. Remember for our h, our x value, it's always going to be the opposite. So it's going to be -3 and then down 1. So I don't know, somewhere around there. So we have -3, -1 is our vertex. Okay. And then since our a value is negative, instead of opening up and to the right, it's actually going to open down and to the right. And then this -2 means it's going to be a little bit steeper than it was before. So we'll draw it kind of like that there. If you want to go to it's like Desmos, or if you have a graphing calculator, you can put this in and you can get a more official graph. We just need the general idea of which way is it going. Is it going to the right? Is it going left? Is it going up or down? Okay? Because if we know the direction and we know the vertex, then we can find domain and range. So our domain here, it is going to the right. So the point furthest to the left here is -3. And then it's going all the way to positive infinity. Okay? And now our range, this one is a little bit different. So this one is going from -1 and then it's working its way down, right? But when we write our range and domain, we always want to start, what's the furthest to the left of our number line? So in this case, since it's going down forever, we actually start by saying the lowest point would be as it approaches -infinity. And the maximum point, the highest our y value can get, is -1. And then brackets around that. Okay? So another way you can think of this, if you're writing out domain and range, if you have positive infinity, it's always going to be on the right-hand side, right? Because it's always the biggest. Anytime you need to talk about negative infinity, it's always going to be on the left, because it's the lowest any number could ever be, is at negative infinity. But that's it. That's our whole thing. So you find your vertex, determine if it's opening up or down, and then use those two pieces of information to calculate your domain and range. Once you get into it, you'll see it'll be like, Ellis, why did this take so much of an explanation? This isn't even that difficult, hopefully. All right, good luck.